point to common features, and then it will drape your image on top of the DEM that is embedded in the LTVT, something that you can update. So obviously, if the more features you have, the better, so that you can end up with a very a geo-rectified image that is very close to the underlying digital elevation model. If you're restricted to an aperture constraint, try to find a very good planetary camera that can make up for that deficiency in a way in the setup. Yeah, but I mean, there's always that limitation. I mean, this was taken by a DMK camera. Yeah, a 640 by 840. I mean, now we're in the thousands, and there has been an advance in terms of CMOS pixel arrays nowadays, which can make up for a limited aperture. This is a basic CMOS camera. It's a ZWO ASI 183 MC that I use for photographic color imagery of planets, and it's a very good and useful CMOS because when you attach a filter that that is related to the color infrared, you can get some really interesting. This is also remote sensing, but this is more in line with photography. You can get a very good sense of the albedo. So this is the kind of level of detail that one can get. This is, mind you, this is from the C8, from the 200 millimeters. So if you have very good weather conditions, transparency, and stable weather conditions, you can get really good